Yeah, good afternoon, students. So it's my pleasure to invite you to this today's session on hardware components. Under that, we are going to discuss about the register file contents. So the motivation for today's session is that now we are going to learn about what are the different types of hardware components that are required for execution of these particular type of instructions in computer architecture and organization. Now I would like to share my screen. So the today's topic for a discussion is hardware components, register file. So the today's lecture objectives are, so this session will develop the students knowledge in understanding the register file in basic processing unit, that is the CPU. So what are the different types of hardware components are there? Under that we are going to discuss the first category of hardware components, that is register file. So we have other types of hardware components also in the processor. Okay, ALU is another component, data path another component, like that we have different hardware components are there. Now in the coming sessions we will discuss other hardware components. Now today we are going to discuss about the first hardware component involved in the basic processing unit, that is the CPU, is the register file. So in the CPU already we all familiar with that we have different types of registers are there in the processing unit. So general purpose registers which are usually implemented in the form of a register file. So which is a small and fast memory blocks, we can say it as, comparing to the hardware memory unit. So this a register file consisting of an array of storage elements with access to a circuit that enables data to be read from or written to any register. So we have the facility to read the data from a register, and we have the facility to write any data into the register. So we have enabled with a read and write capability in the electronic circuit, where it is providing the facility to access these particular storage elements, register files. So the access circuitry is designed to enable two registers to be read at the same time, making their contents available at two separate outputs. That means if you are reading with a single read instruction, so that means you are able to read two registers at a time. So that means you are making the two register contents available in two different output memory operands, that is A and B, for example. So the register file has two address inputs that selects the two registers to be read. Fine. So we have a two address inputs will be there. So which is used for selecting the two registers to be read at a time. So these inputs are connected to the fields in the IR register, instruction register. So that specifies the source registers so that the required registers can be read. So the register file also has a data input which is called it as a C, and a corresponding address input to select the registers into which data are to be written. Okay, so this address input is connected to the IR field. So in the instruction register field that specify the destination register of the instruction. Okay, so we are reading from the source register and then performing the operation, and then the result which we are getting after this operation, so that result will be in the data memory operand C, for example, and then that memory operand C has to be returned to the destination register in the processor. Through this IR instruction register only we are doing all this transfer. So the inputs and outputs of any memory unit are often called it as input and output ports. A memory unit that has two output ports is said to be a dual ported unit. Fine. So generally a memory unit that has two output ports is said to be dual ported. Here we have the input and output ports will be there. So the output of the ALU is connected to the data input C of the register file so that the result of a computation can be loaded into the destination register. So now you can see that the in this following figure shows that the two important ways of realizing the dual ported register file. So in the dual ported register file, so what we are doing here is that the two important methods of realization of this dual ported file is that the first method is the single memory block method. So in this single memory block, so what we have a register file will be there here. So for that we have the input addresses A and B are the input addresses, and then C is the output address here. So then this is what we are calling it as output data. So this is a single memory block we are calling it as. Okay, so the C is also another input we have. So this is a second method of realization of this dual port, which is called it as a two memory blocks. So this is one memory block having address A, and this is another memory block having address B in this register file. So instead of here two addresses for a single memory block, here we have one input address for one register file and another input address for another register file here, and then this is the output A and this is the output B, and this we have a address C will be there, and these are connected to a what we are calling it as the input data, which we are calling it as. Okay, so these are connected to these two blocks are get connected to this address C, just like how, so this is address C and this is also address C, so both are tied together and it is connected to this here. Okay, this one and this one. Fine, and this is a input what we are calling it as input clock we can give it as. Fine, so this is a two memory block mechanism here. So now the reflection point here is that, so what is the register file, and the lecture level practice problem corresponding to this today's session is that, so analyze the two ways of implementation of dual ported register file. So how this register file, dual ported register file is implemented in two different ways, and you have to analyze the pros and cons of these two important ways of implementation of this register file, dual ported register file. So single block memory and two memory blocks. Fine. So this is what the today's session is. So after completion of this today's session, the outcome of this today's lecture is that, so you must be able to analyze these two important methods of realizing the dual ported register file in a computer system, that is a basic processing unit, how this register file system is uh, implemented by making use of this single memory block and two memory block dual port mechanism. Okay, so thank you students, thank you one and all.